Where was I? We're going to be talking a bit about how we've moved from a culture where data science teams would have to hand off to at least one or two other teams in order to operationalize the solutions they were building, to a culture of ML ops. I'm going to start my talk actually by defining what ML ops means to me. I'll go into a bit of context about the journey we're on at M&S, both in terms of our digital transformation and what we're up to in our data science teams at Marks & Spencer. And then I'll get a little bit more technical. I'll go through the tech stack that we're operating with at the moment, and some of the challenges we've been facing over the last year or so, deploying machine learning. And then I'll go into details about how we've tackled those challenges, how we've set goals and measured our progress along the way as well, bringing machine learning best practices into our BAU. So when we talk about ML ops, what exactly do we mean? I think, much like the field of data science, there isn't really a commonly or consistently defined meaning of ML ops. For me, I think this quote by, I think he's still the CTO, still the CTO of Amazon. For me, this epitomizes what we should be aspiring to do with our data science teams, and enabling our teams to build, run, and operate the systems that they're building, without having to hand off to other teams to operationalize those models themselves. And Vogel's, when he made this quite famous quote now, his reason for this principle of you build it, you run it, is because he believed that, developers are much more capable of building high quality code and high quality solutions when they have to deal with operational issues themselves, and by giving them those responsibilities, you're bringing them closer to the customer so they can learn and gain feedback about the impact of what they're doing much more directly, and you're giving them more accountability, driving more ownership as well. And for me, this represents really what MLOps should be aspiring to achieve. I think to break this down a little bit more, I think it's very easy to get fixated about technical details and tools when we talk about MLOps, but for me, it's about much more than just that. For me, there's elements of establishing a culture that's needed to run MLOps at scale. It's about establishing good processes that work for our teams, and then it's around getting appropriate tools that can help us automate and standardize tasks, and build high quality systems as well. I'll give some examples of each three of these areas a little bit later on. So as promised, I'll talk a bit about the journey we're on at M&S. I assume most people here will have heard of Marks & Spencer. In case anyone hasn't, we're a large retailer formed over 130 years ago out of the UK. We now operate in over 30 countries around the world. We have over 1,500 stores around the world. We have one of the most frequently visited clothing websites in the UK. Perhaps a bit surprising, we don't necessarily have the best reputation for clothing, but certainly amongst certain demographics, we are extremely popular. And many of you might have heard about some of the turbulent times both M&S have had, perhaps over the last 20 years, and other high street retailers as well. Over the last 10 years, we've attempted several digital transformations. They've not necessarily been a success. The current transformation we're on is showing positive signs, but there's still a lot of work to be done to really transform how we operate. So what digital transformation means to us at the moment. So our digital transformation strategy, I think this was released a couple of years ago. So we're aiming to be a digital first business by 2023, 2024. If you think about what that means, that's quite a lofty aspiration for a business with 1,500 stores, some of which, have been around since before the war. Significant amount of time. But the way we think about how we can become digital first, it's around building consistent, seamless experiences for our customers, consistent in any channel that they wish to deal with us, whether that's in-store, online, and via marketing channels. It's making better use of our data to really understand our customers and their needs. Using personalization to drive loyalty and provide things like recommendations and services that are really tailored to their interests and their needs. It's around developing a culture internally to put data at the heart of our decision making, using things like machine learning and AI to scale and optimize and automate decision making systems around the business. And it's around cultivating a culture through scaling out new ways of working, such as cross-functional agile teams, and a culture of experimentation around the business. In terms of data science, our remit across our team spans the whole business. We're ordered into two different areas, customer-facing applications of data science, of which my teams are responsible for, marketing, digital experiences, and then we have a loyalty team as well. And then we have a non-customer-facing applications of data science, loads of really, really interesting opportunities for data and data science. In that space, we've had a huge impact doing things like price optimization, markdown optimization, supply chain optimization, and then we're also recently started doing retail applications of data science. So these are in-store applications of data science. We've had success launching data products, for example, for store managers, using techniques like anomaly detection that's shown really promising. We've tried them in a small number of stores and are beginning to scale that capability, beginning to dip our toes in the water around image recognition systems and a number of applications for that in store as well. Then underpinning all these teams, and I'll be talking a bit more about this later, is what we called here our data science engine, or our data science platform. It's enabling all our teams to operate autonomously and at pace in a standardized and high way, and ensuring we're building things to a high quality. So in terms of our journey so far, so I joined M&S just over a year ago now. In that time, we've grown significantly from around 8 people to around 26 people now, and we're still growing fast. We've moved from just one sub-team to 4 separate sub-teams in those 2 different domains I just mentioned, working across at least 12 different product or mission teams, as we call them now. We've gone from having 0 models in production when I joined M&S to at least 11 different models, or I should say use cases in production now. I think at least one of our use cases involves several tens of thousands of models. And we've had a large impact so far. We've driven over 70 million incremental revenue in the last year, and we've got lofty aspirations to continue increasing that over the coming months and years. Okay, onto our tech stack. So, we're relatively tools agnostic, but, we have some pretty vast data sets. So we make heavy use of Spark, and we use Databricks to help us manage those Spark clusters. Heavily use the Azure stack, using things like Azure Data Factory, Azure DevOps for orchestration, CI/CD, which we now have in place. Model training stack, again, is fairly agnostic. We've got various different applications using different Python libraries there, using Azure ML, MLflow for reproducibility, model and experiment tracking, using tools like New Relic, Great Expectations for monitoring and validation. And then we have another of different serving options. Some, just using batch jobs and creating dashboards for colleagues using things like Power BI. We have a cached in-memory data platform called mParticle, which is a neat tool, event-based platform that can serve data with low latency. And then some of our applications as well, we're using Kubernetes to expose API endpoints. So I'm going to move on and talk about some of the challenges we faced deploying ML now, particularly when I first joined the business, when we were attempting to deploy some of our models for the first time. I think when I joined, I realized very quickly that our ways of working were really not set out well to really empower our team. They had very little ownership about operationalizing their models. There was a huge communication overhead to sync with many different teams who were involved in the process. Ultimately, there was a lot of handoff between different teams who'd have different permissions to do certain tasks. And with each additional handoff, more and more context about the business problem that we're trying to solve, about the code that was being written. Really, the gold was all being lost. Having specialists, disconnected teams with limited permissions, resulting in handoff of work and code, created many dependencies on different teams, schedules, and priorities. That was resulting in very slow release cycles. We were batching up lots and lots of changes in one go because it's so painful to actually make any changes or deployments to production. That was causing lots of risk of bugs and delays. Because the changes are so large, it's taking teams a long time to action them, which was causing delays, and it was meaning we would have to schedule things in sometimes many weeks in advance to get support. This was all slowing down the feedback loop, our ability to learn, both in terms of the impact of our work on customers, but also to pick up technical learnings about our infrastructure and constraints that we had in our production environment. And ultimately, it was resulting in frustration and feelings of disempowerment in our teams. So off the back of that, we were successful at feeding back some of our pain and some suggestions about how we could make life better for our data scientists. And I think around the start of this year, I would say that was the genesis of our ML Ops journey. And I'll tell you a bit about that journey now. Firstly, the way we pitched the culture that we wanted to establish at M&S was that we wanted to aspire to achieve the following goals. We wanted to empower our data science teams to build, run, and operate the systems that they were building. We wanted to accelerate their teams so that they could work quicker, get feedback on what they've been doing much earlier, and deliver value sooner too. And then we also wanted to build quality into our process, ensure we're building safe, reliable systems. I'm going to talk a bit more about each of these goals now and how we've addressed them. So firstly, what we mean about empowering our team, we really mean, that means reducing handoff, so teams have more responsibilities, more accountability, more permissions. To do that, we've had to fight to get those permissions to the teams. At times, we've had to introduce new processes. and yeah, sometimes technical processes, sometimes non-technical. So, for example, implementing things like CI/CD pipelines, good linters, so that we can get feedback on the quality of the code that we're attempting to push, and get some good automated tests and checks in place. And some of it as well is around standardizing our design patterns and documenting common tasks and common patterns so they can be reused across teams. To give an example of some of this, I'm sure most of you here will be aware of, say, like the data science cookie cutter. We've used that in our teams, like a slightly modified version, so that it can install commonly used tools for our workflow. We've also templated kind of like a code design using the command design pattern, which again helps really modularize our code, helps us build lots of things like the different testing steps and validation steps in a nice, readable, modular, and repeatable way. In terms of our Accelerate goal, I'd be keen to see a show of hands. Who here has heard of this book, Accelerate? So probably maybe around 5 or 6 people for the benefit of those in the audience. I think that this book has been really central to our thinking about what we should be aiming to achieve with ML Ops. I think the book, I think it was published maybe 4 years ago now. Really, the central premise of this book is that they try to make the case for the business value in having a DevOps culture in a business, and actually they've undertaken a lot of research and statistical analysis to try and establish a causal link between DevOps maturity and in particular performance on these 4 KPIs you see here, and the overall success of a business. They argue where teams and businesses have the right processes to enable their developers to work at pace, then the learning cycle there means you can try more things, and that directly correlates with the value being created by these businesses. So while this was proposed as a rationale for implementing DevOps, it's still all of these KPIs are just as relevant to data science teams and to ML Ops as well. And the 4 KPIs: lead time, that represents the time it takes from committing code to having that code running in production. Deployment frequency, can be correlated with that. It's the number of times teams are able to push code into production, say per day or per month. Mean time to recover from failures. I think that the rationale for that is in the complex world that we operate in, failures are inevitable. So rather than measuring the number of failures that are being made, it's much more informative to measure the time it takes to recover from those failures. And then, change failure rate as well represents the number of the proportion of changes that teams are successfully able to make without breaking things. So we've taken steps to address all of these, and I'll show you a bit later like where we've come on our journey. Like we've made quite significant improvements in many of these metrics over the last nine months or so. And then finally, in terms of quality, like we've been heavily informed and guided by this kind of classic paper by Google, the ML test score. I think that it's a great paper. It proposes a set of machine learning best practices and enables you a way to quantify the maturity of the systems that you're building. So they detail, I think, 7 criteria in each of 4 different areas to help show the different types of monitoring and tests that a mature machine learning system should really be having. So yeah, the maximum score would be 7 out of 7. I think we pragmatically aim for a score of 4 plus in our projects. I'll show you a bit more about some of the things we've done, some of the ways we've added tests into our systems. Apologies here for the slightly wordy slide, or slides I should say, because I've got a couple more like this. But yeah, in terms of data tests, we've heavily used Great Expectations, which is an open source Python library, to build kind of data feature validation steps into our code. This has been really helpful for monitoring things like data drift, and it's certainly helped us debug debug issues that have happened, and where models have not performed as we expected. This has been extremely helpful in helping identify the causes of those issues at times. Model tests. So yeah, there are a few types of tests that the authors of that Google paper propose. Validating that a simple model is not better than a more complex model. Having that test automated, is a best practice. Having automated tests that all the features in the model perform better than just having a randomly generated feature, is a good way to sense check whether features are really adding anything. And I think that the last one I've listed here, evaluation slicing, they call it, I think is really critical as well. Just ensuring you're automatically looking at model performance or other key metrics on different slices of your data can give you really critical feedback about the impact of your model. Finally, monitoring and infrastructure. We weren't using model registries and things like that when we set out last year. Now we have registries and we have automated tests, so that every time we retrain a model, we have a release process that will ensure that model is outperforming an incumbent. Integration tests have really helped us improve our safe release. Our safe release. I forget what the metric's called. Percentage. And having tests to ensure that features at inference time having the same impact as at training as well, it has been helpful. It's a classic pitfall of any machine learning system that things can be a bit different at inference time versus training. So finally, other important considerations that have helped us progress at M&S. I think we're running low on time, so I'll move swiftly now. But having different team structures has been really impactful for us as a business. So we're in the process of rolling out what we call mission teams in the business. These are basically just agile, cross-functional teams, typically consisting of product manager, data scientists if relevant, maybe an analyst, and software engineers. That's been really important to ensure that a team has the right skills and permissions to tackle a problem end to end. This results in less reliance on other teams. So it's enabling teams to autonomously propose solutions to problems rather than have solutions imposed on them, which at times has been a problem in legacy organizations like M&S. It's enabled teams to ship software releases early and often, creating small deployments which are much less risky, and enabling them to deliver value and learning sooner. Finally, I think that this is a big one that we've been coming up over the months as well. I think probably many of you will have seen the huge amount of different tools and startups operating in the MLOps space. It can get quite overwhelming just trying to make a decision as to who we should be looking to explore or partner with. Also, which new tools or tech we should be trying. So we've recently started a new tech forum to evaluate data science tools, technologies, startups in a lightweight way. So we do a lean coffee type discussion where anyone can propose tools, technologies, startups to evaluate, and then once a month we have a discussion, in a kind of retrospective style format where we can offer opinion and ultimately come out with a rating to help us prioritize whether we should be giving some of these tools or startups more time, or whether we want to park some of those things for later. So in terms of the progress we've made so far, something that's very impactful for our teams, reducing the number of manual steps in our deployment process. I think measuring that and impacting on that has been really powerful for impacting on the Accelerate KPIs. I think at the start of the year, there were at least 8 manual steps in our deployment process, and often going through multiple teams. We've reduced that to just 1 or even 0 in some situations now. That's enabled us to have a much faster time to recover. There are times where it might have taken us 72 hours to recover from even a simple failure, at the start of the year. And, we're now empowered to be able to do that, ourselves, which, that could take 5 minutes to fix sometimes and deploy. Some of the uptime of our services was terrifyingly poor at the start of the year. Maybe, not much more than 50% success rates. We've thankfully fixed that problem, and much more unusual if something breaks these days. And then being able to establish habits in the team. It's not all actually about technical capabilities. Just establishing a process in a team where teams are pushing to production frequently and not just having very long-lived branches is something that we're continuously encouraging in our teams and reminding people of that habit. And typically, we're meeting that goal of shipping at least 10 releases per month now in small sub-teams. So before I finish, just some recommendations and key takeaways. I always recommend establishing an end-to-end system in production as early as possible when you start a new project. Get out of the research phase as early as you can, and try to establish that path to production straight away, because if it's not easy, the more complex the system you build, the harder it will eventually be to get something running stably. On that note, it's always best to start small, start with something simple and look to iterate once you have it running in production. We found it very impactful not just measure business outcomes, which most people are held accountable for delivering value to customers or the business, but by actually measuring and setting goals around technical KPIs has really helped us improve our processes at M&S. And just keep identifying pain points with your teams and blockers, and just keep improving as you go, and make sure you celebrate that success along the way. If anyone is interested in the things I've been saying today, our data science teams are all building end-to-end machine learning systems at M&S. If anyone would be interested in joining us, we're actively recruiting in pretty much all our teams at the moment. Do get in touch if interested. But that's my lot. Thanks very much for listening tonight.
Brilliant. Thank you very much, Nick. Really, really interesting talk, actually. I think your point at the end about build something simple and get it out and iterate, that's sort of a little bit sounds like the beginning of the DevOps movement for software, doesn't it? When, Agile became a thing. And I think data science is starting to go through that phase now. And, actually, Tatiana, who spoke the last time we had this meetup, said the same thing. She said, they had to do prototypes, and they also had to do that to get business buy-in as well. I didn't have any questions on the stream straight away. So if you're listening online, throw them in the chat and we'll come back to you in a minute, and I'll take some questions from the room. So one over here.
Cool. Yeah, thank you. That's a really interesting talk. So I noticed your stack then you were using predominantly Azure with Databricks there. So are you using notebooks in production? And then follow up on that. If so, how are you managing with kind of things like unit testing?
So, yeah, it's a great question. We do use notebooks in production, but they're all treated as plain text. And the notebooks, basically just running code. Our code is all in modules, and we deploy that on Databricks by installing our packages as wheel files. So there isn't really any logic in the notebooks. But because they are plain text, we can test them if we want.
Thanks. Any other questions? Yeah, I'm going to go down to the back there.
Yeah, thank you for your talk. You mentioned that when you train new models, you compare them against previously trained models. Is this in terms of accuracy, or are you also monitoring other things?
Yeah, it's a good question. I think typically, in terms of the model release process, I mean, it can differ from project to project. Typically, it would be an accuracy metric that we'd be monitoring. There might be like some slices of data that we might be monitoring other metrics for as well, as kind of like a hygiene factor, making sure we're not performing worse on certain segments. I'd say, we're probably at the relatively early stages of having that process in place. I think certainly in my teams, we've only been doing that for a month or two. So I'm sure there's many ways we can improve on that process. And, if you or anyone else has other ideas there about how we could do that, I'd be very open to hearing those suggestions.
Cool. It's a good point. We're all here to learn from each other. So go and mingle and share your thoughts with Nick afterwards. I had a question here, and then I'll work my way forward again.
Thank you. Regarding the prioritization, how do you keep in touch with other departments, and who exactly is developing the strategy for operations?
So, if I've heard you correctly, your question is how do we work with other departments and prioritize use cases? It's a good question, and it varies a bit. I think in some cases, we've worked with consulting firms who've come in and highlighted all these use cases that we could be working on, and that's gone right up to the board level, and we've kickstarted a lot of teams in that way. So in my area, we've typically not done that. Like, we have different product teams who typically will be set a given problem, and that problem will be set by our leadership teams, and then the teams will work out a strategy for tackling that problem, and even there are certain things that we proposed ourselves from within our team, and typically we might write a one-pager, circulate that amongst some of the appropriate leadership teams, and if we can get buy-in on that, then we can either start, if it's a small thing, we might be able to just start within our data science team. If it needs more support, then sometimes new teams are started up off the back of those initiatives.
I got one back here as well.
Thank you for the talk. Have you come across any disadvantages or frustrations with the process of switching to ML ops?
I think one potentially large issue is it's a culture change, and actually requires there's a learning curve. Not all data scientists necessarily want to own end-to-end machine learning systems and take on all the responsibilities that entails. There can be a lot of engineering work needed to do that. So that cultural shift, particularly with people that might have been with us before they needed to do that, it can be a bit of a journey to bring people along with us on. And likewise, just ensuring we're upskilling our people, lowering the barrier to entry by kind of standardizing or documenting best practices, has been really important. I think we try to frame it as a really important learning opportunity for people. Like, I think in order to build and operate machine learning systems, you do need to develop engineering skills and be aware of engineering best practices. And I think that's critical for any data scientist who does want to operationalize their work.
Yeah, I guess you can always just show them that slide you had at the end where, the one where you've gone from like 10 manual steps down to 0 and uptime from 65%, which I think there were a few shocked faces in the audience, but to 99, if you can show that to someone, you're kind of showing them the benefits straight away.
Right.
Yeah, do we have more questions? Yeah, sure.
Thank you for your presentation. So I have mostly a question around the cost monitoring of the whole infrastructure. So it's pretty broad. The infrastructure the tech stack is pretty deep. So it's how do you monitor the cost of this whole infrastructure during its lifetime?
Yeah, it's a good question. It's probably one we're not nailing that well at the moment. Like we have dashboards to monitor like team costs on Databricks and things like that. Excuse me. We've been fairly fortunate that so far, we've not been too limited by costs. I think over the next year, we will be more deliberate and intentional about being mindful of costs. And I think especially with things like Databricks, it's very, very easy to rack up huge cloud bills. It's slightly eye-watering at times when I look at the clusters that people are spinning up. And you do have to question sometimes whether that huge cluster is needed to do sometimes a fairly basic bit of work.
Cool. Yeah, great question. Do we have any more? Yeah, there's one here at the front.
Thanks. Building on the previous question, how many of these models have, if out of hours needs? So my question really is, how do you manage if you've got to build it, you've got to run it. So what does that mean in the middle of the night? How many models get you out of bed in the middle of the night? And do you just have engineering cover and no data science cover? And how do you manage the interruption of what you've planned into that sprint or that cycle when stuff comes in? Just all those kind of challenges of the operate influencing the build work.
Yeah, it's a good question, and yeah, it's probably one where we're still developing good processes for. We have a relatively informal process now where typically if things break, fixing that bug is usually quite a high priority for a team. I think we've relied a bit on people's goodwill, like when things have gone down at the weekends, where when people sometimes have fixed them at the weekend if they've been available. In the past, things would go down at the weekend, and even when we had ops support, we might get a message at 2 a.m. saying your job broke last night. At times people have put in goodwill and just fixed it on a Saturday morning, but then actually they've not been able to deploy that change until Monday night, or even sometimes the Tuesday. And typically that's much more frustrating for someone if they do some work on a Saturday and then actually, the service remains down, but just because that commit can't be brought into the production environment and until working hours. So there's not necessarily an easy fix, but yeah, I think at times, and especially when we're working on more and more critical projects, yeah, we'll probably have to agree more formal processes for that.
Great. I'm just going to jump onto the stream and see if we've got any questions here. If you still have questions in the room, you can go and corner Nick after this. We're going to have a short break anyway, so sorry. Okay, yeah. Jonathan says, are there any major advantages/disadvantages in using Azure rather than AWS in terms of MLOps and modeling availability services? Sorry, and modeling available services, brackets, I've only used AWS.
Yeah, it's a good question, I think, and it's probably not one I can easily answer. Like all the cloud providers are rapidly developing new functionality. I think I hadn't used Azure before joining M&S. I think I quite like it, actually. It's if anything, I'd say it's more user friendly than AWS. AWS, everything just feels like an MVP. Can be a bit scrappy at times. AWS can be a bit slicker. Oh no, so Azure can be a bit slicker. Sorry. There's some really good MLOps tools in Azure ML, and there's really good MLOps tools in AWS SageMaker and things like that. So, and it's the same with Google Cloud as well. There's more and more good MLOps tools coming out. It's hard to say which is better than which other.
You should get a bit of a view of this from Phil in a minute. So Phil's heavily embedded in the AWS ecosystem, and going to talk to us about his MLOps experience on AWS. So Jonathan, on the stream, stick online and you'll find out a lot more. Tatiana says, how do you arrange training sessions for data science team after setting pipelines/processes without disrupting their work?
So how do we arrange training sessions for teams without disrupting work? It's a good question. Again, it's something we'd look to continuously improve our training. We're increasingly documenting more and more standard practices so people can read in their own time how to do things. That can be really helpful. We have a close relationship with Microsoft. We send pretty much all our data scientists on workshops with Microsoft soon after they join. We always get very positive feedback on that. Likewise, we have like an MLOps team or an ML platform team, typically with an ML engineer embedded in our data science teams, so they can help us as well by pairing with our data scientists and helping them learn from someone with that experience.
Great. I'll do one final question from the stream, and then we'll take a quick break. We've got your company's data spans a number of ML techniques, from time series to recommender systems and outlier analysis. Does the range of ML techniques and complexity pose a problem for your MLOps pipelines?
Yeah, it's a good question. There are challenges with certain algorithms. We at times, we're using kind of product embeddings and things like that, which some of the use cases for that to use in-session data, causes technical issues because latency becomes important. So far we've not found anything that we've not been able to do. But yeah, certain applications are easier to tackle than others. A lot of our applications are actually relatively straightforward batch jobs at the moment, and there's quite a lot of flexibility with batch jobs, how you tackle them. But yeah, when you start to go into the real-time world, then other considerations become much more important, like latency, having good data pipelines and things like that.
Cool. Well, thank you again to Nick. So let's give him another round of applause.
Thank you.
Thank you. For everyone in the room, we'll just have a quick 10-minute break. Go grab a drink, go to the loo, and Phil will get set up, and then we'll do the second talk. If you're on the stream, don't go anywhere. We'll be right back. And apologies for the technical glitch earlier. You only missed me sort of rambling on the stage a bit like I'm doing now anyway. So we'll see you all in a minute.
Cool. Thanks.
Okay, I'm muted. Hello. Okay, good. Hopefully all working without any glitches this time. If someone could just say something on the stream to say that they can hear me fine, that'd be amazing. We'll confirm that in a second when some nice person does. Yeah, so that was awesome to see so many people having really cool little discussions. I feel really bad going around breaking everyone up and saying, can you come and sit down again? But it'll be worth it. Phil's going to give a great talk. You've heard enough from me already, so I'm going to hand over to Phil Basford, Head of Solution Engineering at Inner Wisdom. You're also an AWS ambassador. You'll probably take me through your credentials anyway, so thanks.
Cheers, thank you, and great to see you all. Just like the second time I've been out in person speaking, so it's a new thing post-pandemic to do, so thank you. Yeah, as mentioned, I am from Inner Wisdom. So Inner Wisdom is a AWS completely focused machine learning, data analytics consultancy, and we work with AWS and on AWS to deliver ML data analytics to startups, enterprises, and big companies. And basically, the area of the company that I lead is both in terms of our architecture and also in terms of like our core engineering stroke ML ops engineering practice. So what I'll take you through today is a little bit of a flavour of what AWS has to offer in this space, some of the best practices, some of the tools, and some of the things to do, and hopefully you'll learn a few things along the way. So AWS have been working, I suppose, up until probably a year or two ago, very much on the data science aspect. They've built a comprehensive stack. It roughly breaks down into kind of three main layers. One is the kind of the underlying hardware, and they're always investing in building out the latest GPUs and the latest technology there, and also supporting some of the big frameworks, things like TensorFlow, PyTorch, MXNet, therefore. So they've built a good underlying ecosystem of technology that you can call upon. And then upon that, they've kind of, from a data science aspect, they've built out SageMaker, which is their big data science platform, and then also a number of other AI services to help the everyday developer to start using AI. So things that do voice to text and NLP and recognition and computer vision and all that for you. So they built a number of services. But it has been very engineered towards the data scientists or people getting into ML and using ML. More recently, they have started to embrace and bring on the ML ops aspect and have released things like Model Monitor to help you monitor stuff, and we'll go through that in due course, and things around pipelining and that so forth. But essentially, it comes down to, and I think it was touched on the earlier talk, it's a cultural process tooling thing. It's about allowing your data scientists to experiment, because you always want them to try to achieve the next great thing and to try to prove the value to your business. So it is about how to allow them to experiment and be creative, but also provide the controls and the rigor and the engineering to make sure that's a success. And particularly some of the solutions and things I'm delivering day to day, it's within big enterprises. So it's critical things that have to stay up 24/7, has to be highly available, and lots of kind of explanation and things within the solution. So you have to bring all of that together with automation and other things that I'll go through. So when we go on to AWS, generally the way to start and think about how to approach ML ops is to look at something called the well-architectured framework. It has 5 pillars. Operational excellence, that's about how you run your models in production, how you deploy them, and think about how, and it's kind of some of the like blue-green aspects of deployment. It's about security. I'll go through that a little bit of detail, but you need to put security around your models, think about security. Some of these models you'll be producing probably use personal information or financial information or things sensitive to your company. So you have to think about building those controls and also things to aid with regulation and security. Next thing is cost, and I'll come back to that a bit more detailed, but it's the cloud. It's going to cost you money one way or the other. Make sure it costs you the least amount of money is generally the way to go. So it's about running how you run your different things about training or inference or whatever, and how you reduce the costs and make sure they're as optimized as possible. It may be that you do have to spend that money, but you want to spend that money wisely. And then it's about performance, and particularly in some of those situations that I mentioned a few minutes ago, you want it to be scale. You might think about real-time inference and that kind of thing, where latency is critical, and you need to make sure that your response time was in the umbrella you set. So you need to look at the performance and the scalability. So when you process millions of requests per minute, tens of millions of requests a minute, how it scales up as well for some of those real-time processes. And then the next thing is resilience. So things like high availability, or things like recovering from failure when things go down. Some of those things mentioned actually quite a bit earlier. So it's about how you address that. So when I'm approaching architecture, MLOps and ML architecture, I'm looking at all those 5 aspects essentially. And SageMaker is one aspect that I spoke about a minute ago, but to help with those different aspects, so AWS have a peripheral of loads of different services. What I tend to look at is the serverless way of doing stuff, and that's generally on AWS the best way. So I'm looking at things like Lambdas, API gateways, stuff like that, step functions, event bridge, stuff like that. And it's all about how I can engineer and orchestrate the workload for the best of those five outcomes. This is kind of an example architecture and this architecture scales quite a lot. We've got up to 4 million predictions a day on this architecture, and the heart of this is SageMaker. But I just wanted to show, if you're embedding it within a company, you probably want to put it behind an API. So you want to implement that API. You want to integrate that then with your model, and then you want to do things like integrate the data pipelines to bring the data in from your whatever sources you have. This particular one brought it from an on-prem database, brought it in. We've done ETL, and then transformed the data, and then did feature engineering, and then it uses actually live reference data as well as part of a feature store in DynamoDB to do the inference in real time. It also achieved a low latency of about 130 milliseconds at the 95th percentile. So it's a high performance system that is mission critical for this customer of ours. Security. So I think that's probably. I was talking to one of my colleagues the other day about security and trust and that kind of thing. I think probably the next buzz term, just to give you ahead of the curve, it will be MLSecOps will be the next thing. What we mean by that, and I think that's where things like model registry and stuff are coming in. It's that being able to securely run your workload and provide that explainability to it. So it's very important that you use kind of all the security controls that the cloud platforms provide. For AWS, that's things like IAM. It's making sure that your data is encrypted, both at rest and in transit. It's making sure that you don't leave your data open to the public internet. We all hear the horror stories. Try not to do that. Try to make sure you lock it away under safe and key and prevent people getting to the data. And then it's also things like running things out, and we see a lot of that is like we have to run things within a private network inside of VPC and AWS terms to make sure that the data and the traffic does not leave the kind of wider corporate network. So there is kind of a whole lot of regulation and compliance that we have to take into consideration. But most importantly, and I try to explain this every time, it's like if you don't need the data for your specific job, don't have that data available. So only use the subset of the data you need. So don't go near the PPI data or the personal information or the payment data if you don't need to. It's keep away from it if you don't need to use it. I'll use it if you need to, and that solves a lot of your problems in the kind of regulation and security space to many degree. So we generally look from an ML ops point of view in Wisdom at two kinds of changes. There is changes that happen on the current data and change regularly. And it's about either responding to that change or updating your models. So a good example of this is a client who's using NLP to do some address recognition, they take strings and they'll give out a location based on it, is that they are continuously retraining their models and adding to their models. The nature of the data doesn't change. They just need to keep those models up to date. It's going to degrade if not. So this particular customer, we have to retrain their models quite frequently. So that's kind of that, or drift. So hopefully some of you know what drift is. Basically, drift is when the accuracy of the model drops, or whatever you're using as your performance metrics, and then basically it's retraining that on more up-to-date data to raise that back up. So that's also drift. So that's one of the kind of ways that we look at as ML ops. The other one, and it comes back a bit to that more experimental stage, is that sometimes something changes quite significantly. So there may be a new technology come along in AWS or wider, or your data scientist might have a grand new idea about how to evolve the model to its next major iteration, that kind of thing. You might want to change the algorithm, you might want to go from a linear regression to a classifier, that kind of thing. So we treat that more as a bigger iteration change, and that's normally led by the data science, but then we build out a pipeline of how to then get that promoted from their code into production, and then fully automated, and then adopted as the next productionized version of the model. So AWS offers a lot for training, a lot of ways of different training, and you can spend a lot of time on your training, and they have quite a vast way of things to look at. So it may be that you can train a model faster by running more jobs in parallel, and there's cases where we do that, where you may be running thousands of training jobs at the same time to get it within your business time window that you need to get it delivered in. Or it may be that you have a particular big model that requires things like GPU parallelization, that kind of thing, or data parallelization across more than one instance. So training typically, and I'll come on the cost in a minute, but training is very important, but inference is also increasingly important. But it's important to make sure you're on top of those aspects of what's happening and understand maybe how to improve it. And the other thing to say is that it's an iterative process. You may start off with quite a slow training process because it's the first iteration, but you may be able to look at it again, reevaluate how you train it better, how you can tweak the training, run more jobs, less jobs, different instances. So the important aspect is don't just accept it as the completion of the data science work, that they can train it on something. You have to spend time thinking about the best way of training it. You may want to feed it data gradually or in big batches, and that will reflect exactly kind of how you go about your training. But the AWS have quite a lot of different options that are available to you if that's the case. So in the wisdom, we kind of see 6 main ways of doing inference. Okay, there is only 2 really major ones, and that's batch and real time. But for us, real time breaks down into 3 other ones, and batch is a little bit breaks down again. So there is big batch and micro batch, basically. So a lot of things we see is things that run every night, that kind of thing. They take quite a few hours to run. That has a very different nature than a micro batch, which is running every maybe 10, 15 minutes on a lot of data. So we have those kind of different capabilities and different ways of doing inference. We also have edge as well, which is things like running computer vision models at the edge. So we have lots of different ways of doing inference. And real time is the one that breaks down even more to us, and it's quite interesting hearing earlier. Basically, we have proper real time, which is low latency, high throughput, thousands of requests per minute, which a lot of our stuff I spoke to really aids. Then we have the other 2, which is basically like event-based inference. So something happens, it triggers an event, maybe a recommendation engine, that kind of thing, and then it feeds back into a process asynchronously. So the important thing about proper real time, it's normally synchronously, and the enterprise has to call, the product has to call it and get an immediate response. With in the near real time one, it gives it every now and again, it gives it in a response, and it's asynchronously. And then we have occasional, which is a little bit more to the right of that, which is basically there may be 1 or 2 requests per day, but when they do come, they have to be fulfilled. So that's about running stuff in a hot manner, but not maybe giving it all the beans and the grunt of maybe full real-time inference. So we spend a lot of time concentrating on the type of inference, because that will be very indicative of things like cost, performance, and latency to the end business. So it's very important that we understand that, and that's a very important part of our ML ops. And this is where it gets super deep. So basically, SageMaker is wonderful, but underneath it all, it's just Docker. Okay, so they're running Docker containers for you, but they're taking all the heavy lifting out. So they're doing things like helping with the monitoring, helping with the deployment that we're coming along to in a minute, and doing lots of putting it behind a nice service that auto scales and that kind of thing. So if we're doing lots of real time and we're doing lots of batch inferences, we tend to use SageMaker to achieve that aim. If we're doing more the occasional stuff, we're probably using things like Lambda without SageMaker and customizing it to the workload. SageMaker basically supports, like I said, all the frameworks. So the way to include that is specific Docker images for each framework. So if you want to use TensorFlow with a GPU, you include and you'll use the appropriate image. Why is Docker so important? Because it's the way they scale it, basically. So when you host something on SageMaker, especially real time, it will set up your number instance. Each instance is running a single Docker container in its entirety, and that's basically what you're paying for. If you want to do high availability, you run more than one of them. If you want to do other things like AB, you've got to you can share the container. So container is key, and basically you can have multiple variants, being able to experiment in real time and run A/B tests, and also do these days with Model Monitor, capture those predictions. It's just the essence of kind of SageMaker, but SageMaker is kind of built for machine learning and has more capabilities than ECS natively and that kind of thing. So we tend to use SageMaker for lots of our kind of real-time inference. Why is that important? Well, this graph shows a kind of experiment I done one evening. Is that scalability on those really high workloads? What SageMaker takes care of you is that scaling in and out. So if you, on particular days, you might be doing a low number, or on peak days, you might be doing a high number of predictions, and using the SageMaker auto-scaling capabilities that it has, it allows you to scale. So we've seen it go up to 4 million predictions, but kind of this shows how auto-scaling kicked in and gives you a consistent latency. And the reason why that is important is because that can use that latency. If your instance tends a lot of time spending a lot of CPU, the latency will increase to a point where requests will start backlogging and the whole process comes down. So if you're doing, let's say, those critical response times, then you need to look at things like auto-scaling to meet your need. And coming back to the kind of the deployment aspect, so SageMaker also handles for us lots of the deployment issues around what type we want to do. So you can do a rolling deployment, and that's one of the most typical ones we will do. Basically, it will start up, every deployment, it will start up another set of instances and then close them down afterwards once the new instances come healthy. So we do that. It also do blue-green, so if you want to deploy to your old model and your new model side by side, you can then kind of do that and use you can combine that with the canary approach. So you can send 10% to your new model and 90% to your old model, and you can see the real actual impact of that model and has it improved or degraded against the previous model. So you can make a decision maybe to roll it back or proceed with the full deployment. Likewise, you can kind of then knock it up to the next level and have linear deployment. So over time, you can start increasing the number and the amount of traffic going through your new model as you get more and more happy with it. So this is one of the things I talk about quite regularly. For me, one of the most important aspects is we talked about the inference and the training, but the most important aspect for me is actually the monitoring of models, and that should give you a very strong background for your ML ops and why ML ops are there. So the key for me, the key number one matrix is always, is it delivering what it's meant to the business or the problem it's trying to solve? So you need some sort of overall KPI that says this model is delivering what it needs to deliver for me. It's not a data science matrix. That's the next one. This needs to be a KPI of like, is it predicting the right number of addresses or something? So has the addresses improved or that kind of thing? It has to be a real KPI, normally led by the business. And I'd say actually defined probably before you get started. It's in the problem statement. It's something you're trying to do. Have you improved like customer satisfaction by 80% or something like that? So you want to define a crucial KPI, but it's also the thing you monitor over long term. So particularly what we saw with some of our customers is like as COVID hit, that the KPIs dropped, and it's because the nature of the data has dropped and the models weren't suitable anymore or as suitable anymore to real world scenarios. So the KPI is the most important thing because it will capture that business impact. And then the next bit is the model performance itself. So monitoring and looking after things like accuracy or F1 score, whatever you do, and knowing if that drops, then maybe that's an indication of drift and that you need to then trigger your pipelines and your automation to bring that model back up to date and bring it back to operation and delivering the value you need. So you need to monitor that. What helps, especially in the latter bit, is AWS have Model Monitor now, and that allows you to basically track all of those accuracy measures, put in new ground truth, and evaluate the performance of the model, basically. And then there's good old engineering system performance. Okay, so you're running this stuff at scale, possibly, and you're losing lots of instances. What you want to do is make sure that you're achieving what you want to achieve. So you're looking at things like CPU usage, GPU usage, memory usage, disk usage, those real engineering indicators, but they're quite important because you want to know if you're meeting your demand and things like latency and the amount of requests, throughput, that kind of thing. So make sure that you have lots of that defined, and also things like just health check to make sure that the system's up, that kind of thing. You also want observability and looking inside the inference process, especially at scale. So if you are trying to achieve like 130 milliseconds, like I spoke about, you want to be able to look inside that inference, see what's taking the time. It may be not the model, it may be looking up in your feature store, whatever. But you want to look inside the model, inside the process. So we use X-Ray, which is an AWS tool, but there's things like OpenTelemetry and so forth that you can use in the ML space to do it. And in some situations with some models, we've been able to actually break not just through the SageMaker layer, but down into actually what the model's doing. Especially if we're building custom models, we can illustrate inside there so we can understand exactly where there is latency in the system that we can then hammer out, basically, or where things fail a lot. So there's a lot around observability. But the last view, and the most important view, is your money. You're spending money on this stuff, as I mentioned earlier. So the most important thing is to keep an eye on where you're spending it and continuously right-sizing your load, basically changing the instance size to make sure. And on the left-hand side there, you can see over a period of time we've right-sized the load down and down and down, using actually smaller instances and different types of instances to make sure that it fits. So only use a GPU-based instance when you need to use a GPU. Make sure that you're using something that fits your workload. It's quite important. Inference is going to be your number one cost in the long term, unless you're doing something really, really funky. So you need to spend a lot of time finessing that, and that comes back to just understanding exactly how that model is costing, and then you can think about maybe you can change something of the process. So that should also feed back into maybe it's not a super real time, maybe it's near real time you need, or occasional, and that's a way of maybe also reducing your costs. So it's quite important. And it's also a conversation that you've got to have with the business, because it's delivering a value, but at what cost? So you've got to have maybe think about that. So to make sure that it's delivering what they want, but not costing a lot of money to achieve that. So lots of time needs to be spent on cost optimization, and you can use things like spot instances or reserve instances to lower it. Once you're in steady state, you may be able to use for super real time reserve instances, and for occasional stuff you can start using spot instances, which are a lot cheaper than paying the normal rate, basically. When it comes to monitoring, beneath that, SageMaker has lots and lots of ways of monitoring. And what we do is we try to think about that KPI, think about the workload, think about all the different kind of monitors it needs, and then fit appropriate alerting around that and have it complementary. So, for example, you may set up 100 alerts, but don't make them all go off if it goes down, because that's going to spam your systems like neighbor leave and wake you up at 2 a.m. with 1,000 texts. No one wants that. You kind of think about how you're going to build maybe that health check, and then have one alarm that says, okay, the workload's actually gone down. I need to look, and then have things like CPU. The other thing to do is make sure, it's just overall good engineering practice, make sure you have levels to it. You don't want to get out of bed at 2 o'clock in the morning. You want to be handled in work time. So if something is degrading, something's working more CPU, there's normally indicators, days or hours beforehand that you can do something about. So make sure that you layer your alarms, and ideally tackle, maybe you've deployed a model a week ago and its CPU usage is increased significantly. You want to kind of know that before maybe your peak hits the next weekend. So just make sure that you have that stuff in place, and you have the rigor, and you create comprehensive dashboards to keep track of stuff. So you need to have that kind of deep understanding. So monitoring's good, and then the final stage is kind of automation, and this is kind of, to be honest with AWS right now, there is 100 ways of doing this, and they bring out a new service. So we're going to particularly look at step functions, but there's things like SageMaker pipelines and that kind of stuff that's come out. So there's a few ways to experiment these days with SageMaker and AWS when it comes to these. The important thing is you're thinking about how to take that model and the iteration of that model through many environments and provide governance along that process. So the key thing is to make sure you have a well-established infrastructure. A multi-account layout basically is something we're very into, basically separating your dev work from your production workload, keep your production workload in a separate account, and then have the MLOps and the automation processes promoting it through those layers to give you that rigor and that control, and also the automation behind it. So we generally use about a 3 or 4 account model, and then have another account that is overarching, that's controlling stuff. Foundational to that is make sure you have a good data lake and data foundation. That's probably my main thing about how do you scale this process, is investing in things like making sure that you have a rich data lake, and you invest in things like having a feature store to make sure that you're reusing existing data assets, because you would have spent time getting that data in, working on that data and making that available. And what you don't want is the next use case coming along and doing exactly the same thing again, because it's going to take you a lot of time, a lot of energy. So make sure you have a good, well-defined data lake that's rich of data, which will power all those different models and different ways of working and different opportunities. But also it needs to provide you that scale ability actually across multiple teams. And then you can think about having additional governance. So you can start thinking about bringing in things like model registry to control the promotion through environments, track things for auditability and that kind of thing. So you have more transparency into these ML ops processes. So one of the typical ways we go about building ML ops pipelines is we use a series or number of step functions, and we will use, there's a nice little library called Data Science Software Development Kit, which is basically a customized version of SageMaker, step functions. And that basically allows you to call things like Glue or ECR to do the data prep, and then run it through things like SageMaker pre-processing to do your feature creation, and then onto doing the training, and then onto the inference processes. So I would kind of encourage you all to look at that. But there is, like I say, other ways of doing it now with things like SageMaker pipelines, which is very similar. And you can also use things like MFL Flow and that kind of thing yourself if you want to go that way. So more kind of, it's been quite a brief, but you can go in a lot more detail, and I've written a number of blogs about these subjects in a lot more detail. So you can look through these and look at them, particularly with the real-time inference. I've done a number of experiments around that you can look at, about how it scales, when it doesn't scale, that kind of thing. So, for example, I deployed it on a T instance and that didn't scale well, so we have to upscale it. So we've done lots of experiments around that, and how to also use Lambdas for occasional inference, like I mentioned earlier. One of the biggest problems when you use something like Lambda is that it has lots of constraints around size and packaging and stuff that you need to do to it. So I've also wrote a couple of blogs and videos about how you can build out Lambdas to run data science as well, because that's a really cool option. And I think that's about it. Thank you.
Brilliant. Yeah. Thank you so much, Phil. I'll go straight to questions from the audience here, but I guess I'm going to abuse my power as host to ask the first one. So, yeah, given you're so heavily tied into the AWS ecosystem, what's the biggest limitation that you find, or like the thing you hate the most about it? Oh, sorry, hang on. I need to give you the mic.
It's actually some of that occasional inference. So, as I mentioned earlier, it's a bit of a pain to do Lambdas and stuff with data science because there's packaging and binary issues, that kind of thing. So we have to spend a lot of time fleshing that and getting that to work within the constraints. That's quite annoying. There's quite a steep learning curve, I'd say. It kind of, SageMaker Pipelines is kind of good at it to a certain degree, but to wield all of the potential of these things, there's quite a lot of learning curve to go through. I mean, it sounds a bit daunting, but you can get going really quickly with pipelines in Studio. But if you want to get into the real detail of running really high performance stuff, there's quite a lot to learn about it. So what I would say is, the better way of putting that is, like, a data scientist can get going with Studio and pipelines quite quickly and get themselves to a good stage of delivering something of value. But then you do need like proper engineering, ML engineers, people that have done DevOps and operations and that kind of thing behind it, and the knowledge of how to do that well on AWS to really do that at scale and effectiveness over time.
Yeah, good answer. Actually, I mean, personally had a play with the SageMaker pipelines, and so like to do a linear pipeline seemed really easy. But then I was like, how do I do an A/B test or have some sort of complex router on it? And then it just became really, really difficult for me. And I realized that, that's where you need a bigger knowledge of the rest of the ecosystem. So does anyone have questions for Phil? There's one down here. Great.
Yeah, great talk, thanks. Do you use any infrastructure as code tools like Terraform? And if you do, how do you manage a dev environment with the trade-off between keeping a clean environment that matches your code versus allowing people to modify it?
The short answer is yes, we do. So we're very into CloudFormation. So it's part of the AWS thing. And we're very into it. And so for example, I mentioned the real-time inference. And all of the auto-scaling behind that and the monitoring behind that and everything. So what we've done is built up quite a rich repository of templates that allow us to do that really well. So it sets all the alarms and the monitoring and everything up and the auto-scaling for us. So we do that. And we try to replicate that in most environments. So that's where that multi-environment model comes in. So what we try to do is on the experiments bit is why we will have an account as experiments or sandbox or whatever you want to call it, and we'll hand that to the data science. There's some guardrails in it, but they can pretty much do what they want to do experiments, EDA, everything they need to do to get that first model and do their work. And then what they have to do is then basically productionize that and submit it to a code repository. We normally use either Git, or we use Git, but normally either GitHub or CodeCommit from AWS. And the process takes over that and deploying it in those other environments. So typically, especially pre-production and the production environments are very controlled. So it will only roll Delta and chain sets into those environments. So that's how we kind of give the data science that experimental bit that they can make that change, but have a pipeline that's deploying everything via CloudFormation into it and via an automated process.
Thanks. Anyone else? Yep.
Thanks so much for the talk. So you mentioned M5 instances, right? For inference, you use. Is that enough for computer vision projects? Like, do you super optimize the models, I suppose, to run on M5 for inference, or do you use GPUs as well?
Sorry, I got to run back and forth here. Only got one mic.
So, in example, it was an experiment that uses M5. In reality, we're using, across all of our customers, a vast array of different instance types. So I've got, on some of the occasional stuff, because it's appropriate in that situation where it's not highly available, we're using things that are scalable. We're using maybe something like a T instance, because we want to keep the cost down because it's not needed, and that's where some of these trade-offs come. I'm using high-performance environments where I'm using 3 or 4 M5s or M5X larges to do the workload. Or there's, at the other extreme, there is a couple of use cases where we're using things like a P3 16 times X large, which is a very beefy GPU heavy instance, and multiple of them. And for high availability, we're generally deploying 1 or 2 instances as well. So not just auto scaling, but high availability wise. So a number basically of different instances, depending on what the workload needs and some of the evaluation that we've done to make sure that we are using the right instance for those workloads. And that's what that cost diagram showed, that over time we were able to refine the exact right fit for that workload.
Any further questions from the audience? All right, let me check the stream. Okay, yeah, we have a question here from Jonathan, who says, right, the SageMaker SDK can be complex and the documentation is not great. I'd agree with that. Do you use the SageMaker SDK in production or revert this code into a more familiar pipeline, i.e. Boto 3?
That's a good question. I personally, generally for the pipeline stuff, most of the time I will revert back to pure step functions, because at that point I want the control it gives me. And then when it comes to actually implementing bits of logic, I'm using Python and bits of Boto 3. So that's generally what I do, but also things like the SageMaker SDK is also good for things like starting training jobs, that kind of thing. I find it slightly easier. So I kind of use a mixed approach based on the need and the amount of control sometimes I want over these aspects.
Right, I'm going to do one final question from the stream here. What does it say here? Autopilot brackets AutoML was under the experimentation tab. Was this a hidden Easter egg joke?
Look, no. I suppose from our point of view, and just to completely level with everybody, it's like we have data scientists, and most of our data scientists like to build models. So typically, when we're addressing problems, we are looking at how we can look at them the best and use the skills that we have inside our company to look at them. So we will tend to look at that, but at the same time, we will look at AutoML and Autopilot in AWS, because that's the AWS managed implementation of it, to see if there is a a faster way of maybe getting the first iteration up. So it's like a good way of doing POCs, that kind of thing. So that's why we normally look at it more from an experimental point of view. And normally when we get into production, we are finessing the 5% or whatever that a custom model can do. So we will normally go into that. So that's why kind of we're labeled in that the experimental bracket.
Brilliant. Yeah. Well, thank you again, Phil. So let's have another round of applause. So that kind of concludes the agenda for today. For those in the room, please stick around if you want. I think there are still a few drinks left. Continue the discussions you were having during the break. Sorry that I broke those up. Huge thanks again to Phil and Nick for speaking, and a big thanks to all of you for coming as well. So it's great. There won't be another one of these in December. Looking to run the next one in January. So hope you all have a fantastic Christmas break, and we'll see you soon.